Okay, so an example, and I've shown this, I think, with EdSim a couple of lectures ago, is you can use GPIO port to control like a 7-segment LED. And on EdSim, which you should have been playing by now, you see there are a couple of these, well, four to be exact, 7-segment LEDs. And then one of them is by default connected to. So I think the leftmost one is by default connected to this P1, right? And so you can, and these 7-segment LEDs are named A, B, C, D, E, F, G, and then the decimal point. So there are exactly 8 controllable segments, well, including the dot, right? And it's connected to like EdSim. Yeah, so A is connected to P1.0, B is connected to P1.1, and so forth. Decimal is P1.7. So by setting the bits that are connected to these LED segments, you can make it light up to display different patterns, right? But remember that it's the opposite, right? So to turn on a segment, you don't set it to 1, you set it to 0, because it's similar to the button concept. It's done with a pull-up structure, so that because in order to light it up, you want to create the voltage differential, and so by default it's pulled up, and so if you write a 1, that doesn't have a voltage differential. But to light it up, right, you set it to low, then there's a voltage differential between the pull up and the ground. That's what lights it up. So then to display that 2, right, then you want to light up segments A, B, G, E, D, right? And so then how can you do it? So is that right? I think I tried it in EdSim. I think it's correct. So AB should be on, so 0, 0. I'm going from the right to the left, right? C is off, so that's a 1. D is on, that's a 0. E is on, that's a 0. F is off, that's a 1. G is on, that's a 0. And then decimal point is off, it's a 1. Yeah, that's correct. Yeah, so that's one way you can try it, and it just takes one instruction, and that's it. Simple enough to try. Okay. Now, in the EdSim schematic, they have 4 of them. So how do you control all 4 LED 7-segment LEDs? Well, they need to do what's called time multiplexing. They have another 2 bits that'll select 1 out of the 4 7-segment LEDs to drive. Okay, and so you would drive 1 digit at a time, and you go through them quickly, so quick that your eyes can't tell. So it just goes through all of them. But if you don't switch digits, then it's just one of them. That's okay. Okay, but there are many ways to do this, and this particular one, yeah, that just uses a direct connection multiplexed. But there are other ways to do it potentially more efficiently. So there's a chip called a 74LS48 that's called a decoder and driver. So basically, you would feed it binary value, and it will decode. And so that way, it will generate a map from like a binary coded decimal or 4 bits to these 8 bits, because there's only limited number of combinations you might care about. So that is an alternative way to control the LEDs through a decoder chip that's outside the the microcontroller and outside the LED. But otherwise, this is certainly one way you can control the these digits individually, and you can try all the different combinations you want. Okay. Now, so I think we're getting close to the end. Okay, a couple minutes. Now, so this is an important concept. So we just showed you the output part, but to input, what do you do? Well, in terms of instructions, yeah, it could be as simple as a move from the port, say P3, to A. But you do have to be sure that it could actually input properly. Um, and and also, what's the real meaning of reading from P3? Because at the very beginning, I said there's the concept of pins and the concept of port. By port, I mean the port latch or registers, or it could be a software concept. Whereas pins are a hardware concept. Even though they're connected together, you may get different values. Okay, but instead of treating it as a bug, Intel makes it a feature. So how does that work? Well, it relies on that pull-up structure. Okay. So this means you want to make it, if you want to input, you set your port register or port latch to 1. That makes it a pull-up state. In pull-up state, just like the button, somebody can leave it in pull-up or high value, or they could do something similar to a button and pull it down. In other words, while the port is outputting a 1, it's overridable. Somebody is allowed to pull it down or leave it high. But when it's in low state, there's no way somebody can pull it up. Okay, so that's why it's important. At least on 8051, if you want to input, first set the port bits to 1, and that's safe. If you leave it at low state or 0 volt, there's a chance you can burn something up. Okay, so be careful with this. Okay, and we'll go over some of these concepts again next time.